morning, everybody. So, today we're going to talk about the sum of all the natural numbers. This can seem a bit like strange because, yeah, it's a exotic topic. Uh, at the start, you may think the sum would approach infinity because, well, the numbers always get like larger and larger. So, you may think that the sum may approach infinity, but actually, the sum is exactly minus 112. So here we have like two, yeah, mainly two like strange like ideas. First is that the sum of all the natural numbers has a specific answer, and the other is that is the answer itself because well minus 112 it seems like a little bit random, but actually it's not random, and we'll see who developed this. So, the answer was proposed by Srinivasa Ramanujan. Ramanujan was an Indian mathematician at the time, and well, he's like a mathematical genius. So Ramanujan was writing a letter to G.H. Hardy, that was a Cambridge mathematician, was like work at Cambridge. Hardy was a very well educated person, and curiously, Ramanujan never had like a formal mathematical education. So yeah, it's very curious because a guy that never like went to mathematical school discovered, for example, the sum of all the natural numbers. That's well, yeah, it's curious how he got there because for him to do that, he really needed to be a genius. Okay, so to start, we have this letter that was sent by Ramanujan to Hardy. This letter shows, like, he describes the sum of all the natural numbers tending to infinity as C. Then he plays around with the C, like multiplying by 4 and then subtracting from C. Then there, like, he makes this minus 3C equals to 1 minus 2 plus 3 minus 4 and so on, this oscillating sequence. Then Ramanujan sees that this sequence is equal to 1 divided by 1 plus 1 squared. That's equal to 1/4. And if minus 3C is equal to 1/4, C is equal to minus 112. Therefore, the sum of all the natural numbers is minus 112. But okay, let's take it easy. So we'll break it like let's break it parts. Okay. Let's analyze each part separately, and yeah, let's see how it goes. Okay. To start, we are gonna now see like how he arranges the things. Okay. So firstly, as we saw, he describes the C as you are seeing. Then there's the 4C, and 4C is basically, it's not basically, it is all the terms in C multiplied by 4. So the first term in 4C will be 4 because it's 4 times 1. The second term, it's 2 times 4, so it's 8. The third term will be 14 and so on. So yeah, this is a very basic concept. Now let's see what he does next. Okay, so as we can see, again in the letter of Hardy, to Hardy actually, sorry, Ramanujan, he puts, as I said, every number, like he jumps one number and then puts the result of the 4C. So by subtracting C by minus 4C, we'll obtain this an oscillating sequence. That's 1 minus 2 plus 3 minus 4 plus 5, and yeah, sorry, yeah, minus 4 plus 5 minus 6, and yeah, so on. Okay, so we have our sequence. Now we'll analyze because, yeah, this sequence like minus 3c is equal to whatever. Like it doesn't help very much because we can't get like a real answer out of this function. Okay, so let's see what we can do. Okay, so like, are you still there? Because yeah, I know this is like can be pretty boring to some people, but yeah, it's math. For some, it will be like very cool, and for others, it will be something boring. But trust me, like there's fun in everything. Okay, so jokes aside, like, okay, first we do the subtraction of c by minus 4c. Okay, so we can observe uh, in this way Ramanujan does, uh, we get an oscillating sequence. So it's 1 minus 2 plus 3, yeah, whatever. Now, if we observe the sequence, okay, uh, we can see that's always a positive number, then, a positive, then a negative, then a positive, then a negative, and so on. Okay, so let's like think of like other mathematical areas or like other mathematical tools, okay, that will obtain an like this an oscillating pattern or sequence. If you talk about negative numbers being squared, yeah, you're correct. I don't know if anybody thought about that, but yeah. For example, let's take minus 1. Minus 1 to the first power, it's only minus 1. Minus 1 squared, it's 1. Minus 1 cubic, it's minus 1. Okay, so if or if the exponent is even, the answer will be positive. It's if it's odd, it will be negative. Okay, and okay, so here we have the sign part, but the numbers always increase by 1. Okay, so in like a sequence that has like a fixed it's a geometric series. Yeah, it's a series that like a pattern that obeys like geometric rules. Okay, it can appear, okay, because it appears to be like a arithmetic sequence, because it's always like plus 1 plus 1 plus 1. But as there is a sign, we need the geometric part. Okay, so in standard calculus, we can't define this equation as a geometric series. Okay, but why? If you remember correctly, for a geometric series to happen, the R value needs to vary between minus 1 and 1. So it can't be minus 1 and it can't be 1. Okay? So in this case, the R will be minus 1. I don't know if it's clear, but it will be minus 1. Okay? So in standard calculus, we can't make it, and yeah, we just can't make it, because if we use the R coefficient as minus 1, we will break math, and in a Sunday afternoon it's not cool to break math. Yeah, okay, so if you remember, the sum of geometric series, a convergent geometric series, okay, very important. It needs to be convergent. It will be 1 divided by 1 plus r squared. So as I said, in standard calculus we can do this, but like in variations of calculus of other like branches, we can. So we'll make it. Like Ramanujan, that's a mathematical genius. He has done it, and Hardy, that studied at Cambridge, accepted it. So we'll make it. Okay. So if we put r value equal to -1, we have the sum of the series being 1/4, as Ramanujan said. Okay. So like we are very, very, very close to the answer. But okay, let's calm down, because I know some of you may not be convinced that the sum like will be this 1/4. So I'll do it in a slight different way. Okay. Okay. Don't get out of the video. Okay. This is not a monster. It's just another way of visualizing the previous answer, like the 1/4. Okay. So let's get the expression 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on infinitely. And let's square it. So yeah, as you are seeing, I did square it, but like it's not common to square this way because yeah, it's inefficient, but it's a great way to visualize it. So let's see, for example, the first term in the most left up. Okay, it's 1. Now if we see like downwards, it will always be the same sequence, because it will always be getting like multiplied by the 1, because it's the first column. So we can do that for every square. So we have the pattern that you can observe. But you may be asking yourself, how do we get the sum of this bunch of numbers? And that's a great question. So to get the sum of this square, we sum the diagonals. Okay, so the first diagonal is just 1. The second, we have -1 and -1, so it's -2. So we have 1 minus 2. Then we have 3. Okay, yeah, it's getting strange, because this is the same equation as before. So it's 1 minus 2 plus 3 minus 4 in the next diagonal. Then it will be plus 5 and so on. Like I can't really draw infinitely the sequence, because well, my computer isn't big enough and I have a limited time. So yeah, I'm opting to just stay with this range of numbers. But okay, yeah, we have like a simplification of our equation. So we know that it will be 1 minus 1 plus 1 minus 1 and infinitely squared. Okay, now you may be asking yourself, like again, we have another equation. So how do we get this, like the sum of this equation now? And well, we'll see. Okay, so as I said, there's another method. So to simplify, we can use the same method as before, like apply the geometric series and like the sum, and get the 1/4. But yeah, there's always a but. We can use the Cesar's convergence. Okay, yeah, I don't think anybody know what it is. So it's this basic says that if we have an alternating like answer, because, well, it will vary between 0 and 1, because there's always a minus and then a plus. If we have like this oscillating answer, you just do the mean of like the possible answers, and then you have an like approximation of this like the convergence. Okay, so applying the scenario convergence to this equation, the possible answers are 0 and 1. So 1 plus 0 is 0 divided by 2, because there are two terms. It's a half. And as we needed this equation squared to get like the 1 minus 2 plus 3, a half squared, we have 1/4. And voila, we have like using another method, the 1/4. Obviously, there are other methods like deep, very deep mathematical answers, but I think these two like possible answers are enough to show you like how magical this equation, not this equation, this answer, the solution is. Okay, it's just beautiful. Okay, so we have our 1/4. Then we just solve for c in the equation. Minus 3c is equal to 1/4, and we have the minus 1/12. Yeah, I hope you enjoyed this video. I'm sorry it got quite long, but I like I tried to be very calm explaining this because it can be confusing and tricky. And I also want to apologize by the audio, because yeah, I think it's a bit like a bit rusty, the audio. I'm sorry. In my next video, I'll try to fix these errors. And well, if you have any suggestions of possible videos, ideas, please leave a comment. Okay. Probably the next video will be about infinite series. Probably about some like convergent series. Okay. Or some like Euler properties. But yeah, you'll know when the next video reaches out to you. And well, stay safe and bye bye.